Guys, we've got a minute. I'm going to let everybody get in. Okay, let's get rock and rolling. So today we're going to complete 2.2. I'll call it 2.2b. We've got to go over symmetry and piecewise functions. And then I'm going to review for the test and go over kind of the structure of the test and then, everything like that to take it. No big deal. We'll get there when we get there and I'll go over it. And then housekeeping. So tomorrow I'm going to be off campus, and then Friday I'm taking a comprehensive exams for my doctorate from like 9 a.m. to like 5 p.m. So I will be kind of out of commission the next 2 days. So if you have an issue, with like the test or a question, feel free to email me, but realize I might be in the middle of taking an 8-hour test. So it might take me a minute to get back to you on either day. Tomorrow I'm just going to be gone, so no big deal. Okay, Mason, I think it was Mason, asked about allowing people to come to class. No, I mean, you can come to the classroom, that's fine. And if you want to come in there and sit down and use the classroom to kind of spread out or whatever, your stuff, because maybe, the internet or whatever, that's fine. You can use the classroom. But I'm going to stay in my office because this is the best way for me to Zoom to everybody on campus. So yeah, so no. Long answer to a short question. I'm allowing people to come to the classroom. You're more than welcome to, but I'm going to be in my office, still interacting from my computer. So no big deal. Okay, so let's get going. So that way we have a little more time to review, hopefully, at the end of class. So 2.2 starts with a symmetry of functions. Now there's two types of symmetry. There's even, and then there's odd. Okay? Two types of symmetry. There's even or odd. Even symmetry means we're symmetric around the y-axis. So like a basic graph of something that's even symmetric would be like an absolute value graph. Absolute value looks like a V, but when it's centered on the y-axis. Like if we look at that graph, I know it's not perfect, but we can see that if we fold it along the y-axis, it would be symmetric around the y-axis. This means this function would have even symmetry. Odd, though, is a little different. Odd means we're symmetric around the origin. So a graph that looks like this would be like the x cubed graph. So let's say we had a graph that started there. To be odd symmetric, you would have to go to kind of the catty corner quadrant over here and have the same graph. One way to think about it is kind of like clicking it over would give you the same graph. Okay, so this would be an odd function. So this is an even function, symmetric around y, odd function, symmetric around the origin, not around x, because if you're symmetric around x, you're not a function actually. Okay, so let's look at these though. Really where we're going to start with this is with the equations. If we have an even function, It turns out f of negative x just equals f of x, okay? I'm going to give you an example of this with an equation. So I'll give you an equation that is even, okay? We'll do g of x. Let's say we had g of x equals 3x squared minus 8. Okay, 3x squared minus 8. If I wanted to test, and actually we test these the same way. If I wanted to test for even or odd symmetry with an equation, I would put negative x in for x, okay? So I'm going to put negative x in. That's why we went over that in that last lecture. So I'm going to put negative x in, and I get 3 times negative x squared minus 8, right? Now what happens, and this is why it's called even symmetry, when you raise a negative number to an even exponent, it makes that sign positive, right? So like negative 3 times negative 3 turns out to be positive 9, right? So this negative actually goes away because we're squaring it. So this becomes 3x squared minus 8, right? The negative 8 doesn't change because there's no variable. But the negative x squared, since we're squaring the whole thing, becomes positive x squared. And look, this is what we started with, which is our g of x, right? So therefore, we can state g of negative x equals g of x, okay? And if that happens, and I'll do examples where it happens and it doesn't happen. We'll do an odd example here in a minute. But if this happens, this means g of x is even. Now, side note, that means it's if we graphed it, it would be symmetric around the y-axis, okay? If we wanted to graph it, not a big deal, okay? And I'll do an example. I'll come back and do more examples of even functions here in a second. But let's now switch to odd functions. So odd functions are a little different because when you pop in that negative x, you're not going to get the same thing back. You're going to get negative f of x back. So it's going to change all the signs of the original function. So for an odd function, it just changes all the signs of the original function. So let's look at an example. If I had like h of x, and I'll make one up that is odd. Let's say negative 3x, I don't know, cubed, doesn't matter, plus 4x, okay? So negative 3x cubed plus 4x. So I'm going to plug negative x in. We get negative 3 times negative x cubed plus 4 times negative x, right? So same thing we did before, right? I mean, by plugging it in. But now the difference, though, is we're not raising each one of these to even powers. We're raising actually both of them to odd powers. That negative x really raised to an odd power. It's 1. So when you raise a variable or a number to an odd power, it's going to keep its sign, right? Like negative 2 times negative 2 times negative 2 winds up being a negative 8, right? It's going to keep the sign. So that in turn changes the sign of the term, okay? So this becomes, instead of negative 3 negative x cubed, it's going to become a positive 3 x cubed because the negative multiplies by the negative and turns positive. And then the second term becomes negative 4x or minus 4x, okay? So notice both signs change. Like the original function was negative x cubed. Now we've got positive 3x cubed, or negative 3x cubed, positive 3x cubed. We have positive 4x, now we've got negative 4x, right? They both change. Now, a way you can write this, though, is by factoring the negative out. So if I factor the negative out of this, I'd have, well, if I factor a negative out of a positive, I have to have a negative there. This becomes positive, and that's my original function. Do you see that? When I factored the negative out, it changed the signs, and I have the original function. So this becomes negative h of x. This is odd. It's symmetric around the origin. Now look, you can stop here and tell me that, okay? You don't have to factor the negative out and show me that part. You can stop right here and say, hey, all the terms change signs, Therefore, this is an odd function. Where an even function, all the terms stay exactly the same. That's an even. If we have a mixed bag, it means we're neither odd or even, okay? Neither odd or even. Okay. Any questions other than, I think I just need to see some more examples, Mr. Shirley. Okay, let me think of some other examples. Let's do one that's neither or neither, however you want to pronounce it, just so you kind of see an example of it. Let's say we had z of x, and it winds up equaling negative 2x squared. Let's do a nice little quadratic. Negative 2x squared plus 4x minus 8. Okay? And the question is going to say, state whether this function is even, odd, or neither. Okay? Even, odd, or neither. And to find that symmetry, you're going to just pop in the negative x. Okay? So I'm going to pop negative x in. I'm going to see if it stays the same or if everything changes. So I wind up with negative 2 times negative x squared plus 4 times negative x minus 8, right? Now, when I do that, the first term stays the exact same, right? I square the negative, so it doesn't change the sign out front. So the first term stays the exact same. It's negative 2x squared, right? The second term changes, though, because 4 times negative x would be a negative 4x. The minus 8 doesn't change at all because it's a constant, not a variable. So we're done. We have found what we get when we plug in negative x. So it turns out that, look, it's not even because this middle term changed, right? From positive 4x to negative 4x. It's not odd because they didn't all change, right? The first two stayed the same. So therefore, for this function, it's neither. There's no function symmetry for this equation for this function. It's a neither. Okay. I'm going to steal some from the book, and I want you to try them by doing this. Just pop it in negative 2, and then see, or not take what I'm saying. Pop it in negative x, see if it's even or odd. I'm going to give you a few of them from the book, and I just want you to try them real fast. Shouldn't be too bad. So this is number 24 from the book. It says f of x equals 2x squared plus 4x to the 4th plus 1. Try that one. And then try, I guess 26. So 24 and 26. We've got f of x equals 2x cubed minus 6x to the 5th. So try those two real fast. I'm going to pause this. Keep recording here. So I'm going to plug in negative x to the first term, or first function. And I get 2 times negative x squared plus 4 times negative x to the 4th plus 1. Hey, this is going to turn positive, right? So it's going to be the same. This is also going to turn positive because it's raised to the 4th power. It's an even. That stays the same. The constant stays the same. Hey, this whole function's the same. So that tells me that this is actually even, right? Because it didn't change, okay? That's an even function because it didn't change it. This other one's going to wind up being an odd function. When we plug in negative x, because every term's going to change signs, this is going to stay negative now because it's cubed, so negative 2x cubed. This one's going to turn positive because it's already a negative to the 5th. Both change signs. All terms change signs. So this means this is an odd function, okay? An odd function. And remember, now I haven't focused too much on the graph aspect of this, but if we're symmetric on the origin, we're odd. If we're symmetric on the y-axis, we're even. So if we look at like a few examples of that, other than just the little ones I drew, let's see here. Like if we looked at, let's say just a nice parabola. If we've got a nice parabola that the vertex sits on the y-axis, we're going to have even symmetry. So if we looked at something like, let's say like this, boom, this would be even, right? definitely even. We've got this nice even symmetry going on. Where if we want to draw something odd, it really is like, you got to think like catty corners. So if we had something like, let's say, these are kind of harder. Let's say we had something like that. Well, then in the opposite quadrant, we'd have to have like kind of the mirrored version of it. So like that. This would be odd symmetry, okay? And if you think about it, a few people think of it like this. Instead of making one fold along the Y, the odd, you have to make two folds. So if you fold this once and then you fold it again, you would have the same graph, okay? So like, think about this. If I fold this around the Y-axis, this graph would look like this, right? And then when I fold it again around the X-axis, it's sitting on top of each other, okay? So that's one way to think of it. Where if we have something that's like not symmetric, I mean, there's actually an infinite number of all of them. But if we had something not symmetric, a lot of the graphs that we kind of dealt with before. So like we have something coming up here and then it makes like a weird look that way. And then maybe something like that. Why not? There's definitely no symmetry there, right? It's not even symmetric. It's not odd symmetric. And I can tell you it's not odd symmetric because look, we've got this little piece here. Well, then there's no piece over here because there has to be some symmetry going on there. So it's neither. It's neither. Okay. And then this is not, because it goes to the left here and then it goes like, oh yeah, that's just none. Neither. Okay. Questions before we go on to the next topic. So that's even, odd, neither. So even symmetry on the y-axis, we put in the negative x value, it becomes the same exact function. Odd symmetry on the origin, but we put in the negative x and everything changes, right? Everything changes. Okay, lastly, we're going to talk about the piecewise function, or last topic I should say for the test is the piecewise function. So piecewise function. Piecewise function. Now what a piecewise function does is it splits the graph on the domain at some point, okay? And I'm going to graph one to kind of show you what I'm talking about. And I'll graph by plotting points because it's kind of easy to see this when I plot points. Let's say we've got f of x equals. Let's say we've got x squared when x is greater than 1. And then we have, let's say we've got negative 2x minus 3 when x is greater than or equal to 1. Oh, wait. Oh my gosh, I lied. I don't have white out. Guys, this needs to be less than or equal to 1. Okay? Less than or equal to 1. So we've got x squared. And the book even does something really nice, actually, for these. It writes a little if in there. That's not typical for math to give you a little hint, but it's our function. We're going to use x squared if x is greater than 1. And we're going to use negative 2x minus 3 if x is less than or equal to 1. So if I want to graph this, I'm going to think of plotting points. And I know it's going to switch at 1. Now be careful. At 1, I'm not going to be this top function because I'm not equal to it. But I still want the coordinate because it's where I'm going to put an open circle. Okay? And then I want 1 for the other function too because I'll put the closed circle there. So if I'm going to graph this, I know the switch is at 1. So let's start at like negative 1. We'll do negative 1, 0, 1. I'll do that for the first function. Now I'm going to do 1 again because I want the 1 in the other function as well. We'll do 1, 2, 3. Okay. We'll do 3 points for both and see if we can kind of get an idea of what this looks like. Okay. So for negative 1, look, x is negative 1. If x is greater than 1, I would use this function. So since x is not greater than 1, I need to use the other function, right? X is less than or equal to 1. So I'm going to use the bottom function for negative 1. So if I plug in negative 1, I'm going to put it into the bottom function because my x value is less than or equal to 1. And I wind up with positive 2 minus 3. I wind up with negative 1. Right? Yeah. f of 0, again, 0 is less than or equal to 1, right? It's not greater than 1, so I'm not going to use that top function. 0 is less than or equal to 1, so I'm going to use the bottom function again, negative 2 times 0 minus 3. Well, that goes away. I wind up with 0. Oh, gosh, I wind up with negative 3. Okay, that's my second coordinate. Now, I'm going to put the 1 in, and it turns out this is the function we're going to use. So I'm going to make sure that that's a closed circle. So if I plug in 1, I get negative 2 times 1 minus 3. I wind up with negative 2 times 1, that's negative 2, minus 3, that's negative 5. So I'm going to graph just this part now, okay? Try to do it some service. 3 squared is 9, so I got to be up here more, but that's fine. 2, 3, 1, 2, 3. 1, 2, 3, 4, 6, 7, 8, 9. And then down here, we're going to go down to negative 5. 1, 2, 3, 4, 5. Okay, so at negative 1, I'm at 1. At 0, I'm at negative 3, right? And then at 1, I'm at negative 5. I'm down here. Now, this is going to be my closed circle because that's where it switches and we're equal to it, okay? And this is just a nice straight line. And now I'm going to jump over to the other function, because now what if for the other function, it's when we're actually greater than 1. So I'm going to put a 1 in here, but I'm going to put a big asterisk sign because I can't actually be this 1. It's going to be my closed circle. So if I plug 1 into the other function, 1 squared is just 1. I'm going to plot that, but I'm going to use an open circle, okay? I'm going to use an open circle. And then I go to 2, f of 2. Well, look, 2 is greater than 1, so I'm going to use the top function. So I'm going to square it, and I wind up with 4. 1, 2, 4. And then the last coordinate is 3. Again, 3 is greater than 1, so I'm going to do 3 squared. I get back 9. It's way up here somewhere, so it looks like this. Okay? So there's my piecewise function. Before, look, the switch happens here at x equals 1, right? Now, there is no vertical line, but this is me just kind of showing you what's going on. At 1, we have this switch, and that's what this tells us, okay? Before 1, we're going to be this bottom function. It's just a straight line, okay? Just a straight line. When x is greater than 1, though, we're going to switch over to this quadratic, okay? To this different line right there, okay? So this is a piecewise function. It's split on the x-axis. One side it's one thing, on the other side it's another, okay? Now look, I'm not worried about you graphing these. You can graph them by plotting points. It's very straightforward. We're going to look more at identifying parts of the function, parts of these piecewise. So let me show you what I'm talking about. And I'm going to steal some, well, we'll steal some right from the book. Let's say we've got f of x, let's do g of x. G of x equals, we've got to use a squiggly bracket. But we're going to say it's equal to 2x plus 9 if x is less than negative 3. And then it's equal to 7 if x is greater than or equal to negative 3. Okay? This will be a lot like the homework. It's going to be a lot like the homework. So let's see here. I'm going to give you kind of an ABC. A, I want you to find what's g of negative 5. B, what's g of negative 3. And C, I'm running out of room. What's g of 0? Okay? So let's look at this. Split it up kind of this way. G of negative 5. Well, look, this is our x value. Remember, so what I'm asking is, when x equals negative 5, which one of these are we going to use? Well, x equals negative 5. Negative 5 is less than negative 3. So I've got to use this top function for this part A question. So g of negative 5 would be 2 times negative 5 plus 9. So negative 10 plus 9, so I wind up with negative 1. So the solution would be negative 1. Okay. Negative 3 though is a little different. So now remember our x value is negative 3. Well, negative 3 is not less than negative 3. That's not true. But negative 3 is greater than or equal to negative 3 because of the equal part, right? So g of negative 3, I'm going to use the bottom function. Well, hey, it's just 7. There's nothing to plug in, right? So it's just 7. That one's pretty easy. Okay. And then lastly, g of 0. Again, 0 is not less than negative 3. 0 is greater than negative 3, right? So we're going to use this bottom function. Well, g of 0 then would just be 7. Okay? Because we would use the bottom function. Our x value is 0, and x is greater than or equal to negative 3. 0 is greater than or equal to negative 3. Okay? Okay, I'm going to steal one more of these out of the book because it's not a greater than or less than, it's an equal to or not equal to. So let's say, it's not directly from the book, I'm just stealing it. So let's say we had one that looked like this. 5 over x minus 2 and 3x. Now we're going to be 5 over x minus 2 if x is not 2. Okay? And we're going to be 3x if x equals 2. So I want you to try this one. I'm going to pause it. I'm going to do ABC. A, let's do h of negative 3. B, I want you to do h of 2. And then C, I want you to do h of positive 3. Okay, I'm going to pause this one. I want you to try those 3. It's okay if you're not done. I'm just going to kind of go through these. So let's say we have h of negative 3. That means our x value is negative 3. Well, negative 3 is not 2, right? So therefore, we're just going to use this top function. So h of negative 3 would be 5 over negative 3 minus 2. 5 over negative 5, that winds up being negative 1. Hey, that's weird. It's the same up here. That was a coincidence. Okay. H of 2. Now our x value is 2. Hey, 2 doesn't equal 2 is a false statement. 2 does equal 2. So therefore, we have to use the bottom function, 3 times 2. So we get back 6. Okay. And then lastly, 3. Well, 3 does not equal 2. Our x value doesn't equal 2. So therefore, we've got to use the top function. 3 does not equal 2. This is a true statement. So I'm going to use the top equation. 5 over 3 minus 2, 5 over 1. We just get 5. Okay? Any questions? So this will be more how it's asked on the test. So the homework for piecewise and for even and odd, the homework will look like this. So the piecewise part of the homework, the even or odd part is 17. This is on page 239. 17 through 26. I want you to do all of them. I know if you do the odds, you're probably fine, but there's just not a lot of examples of it. And then 37 through 42. The 37 through 42 is how the piecewise questions will be asked on the test. Okay, so this is the rest of the homework for 2.2, right? The rest of the homework for 2.2. Okay. Questions. I'm going to